So the most important thing about a sandblast cabinet is flow.
Excuse me, Flo?
You need to put media in, mix that media with air, and then exhaust the excess air out of the cabinet along with the dust you've created. My cabinet is from Harbor Freight, but these principles apply to pretty much all sandblast cabinets. In this video, we're going to go over a few upgrades that I did to the cabinet, and I'll explain their benefits. The main upgrade I did years ago was to convert from the pickup tube style that comes with the cabinet to a bottom feed with a metering valve. This is a huge upgrade on its own, but if it's not done correctly, you can still end up struggling with flow. Now, a metering valve by itself is not an end-all fix. I chose to buy a cast aluminum metering valve, and it takes the media that's being gravity fed into the top and combines it with the appropriate amount of air before it gets pulled into the gun. The ratio of air to media is adjusted via an air intake on the metering valve itself. I've had a few different air intake valves over the years, but I find that the quarter turn ball valve with the handle is the one that works the best for me. Other metering valve options are to use pipe and pipe fittings to build yourself a DIY assembly, and there are countless videos on YouTube showing how to build one. With this setup, you'll be switching from a trigger style gun to a pedal controlled gun, so obviously, you're going to need a foot pedal. The pedal I used came from Eastwood, and honestly, out of the box, it kinda sucked. I had to do some modifications to the pedal to allow it to move air more efficiently. Remember, flow is the most important thing, and the Eastwood pedal had fittings that dropped down to smaller sizes, and that restricted the flow. If you plan on using this pedal, take any small fittings out and replace them with the largest that you can find. You can also find this pedal by Econoline, and it seems to be pretty well made. I use 1/2-inch air hose in and out of the pedal, and a 1/2-inch air hose makes its way up to the gun. The gun I have is normally used with a pot-style sandblaster, but it's been working great in my Harbor Freight cabinet, as long as you do a small modification that I'll get into later. I chamfered the fitting edges on my lathe, but you can do this with a large countersink and a hand drill. The media feed to the gun ended up becoming the bottleneck in my system, so I'm going to address that in this video. The hose started to kink because of how it was routed in the cabinet and was causing the media to clog. One of the biggest contributors to clogs is moisture in your air, so to fight that, I use a refrigerated dryer. You can go with the method of copper lines on the wall to pull moisture out of the air, and I've done it in the past, but when it comes down to it, a refrigerated dryer really works the best. I know there's also the after cooler modification where you run some sort of transmission cooler between the pump and the tank on your air compressor, and that works great, but unless you have a good way to evacuate the moisture that it pulls out, it can end up causing problems in the end. While I'm on the subject of air, I want to talk about air volume. Not air pressure, air volume. Along with the biggest fittings, you also want the biggest air lines that you can manage in your system. My shop has 3/4-inch PEX run throughout it, and from the compressor to the cabinet, there are a total of 0 quick connects. As you can see here, a quick connect is definitely a restriction. If you have a smaller compressor, a 1/2-inch airline will work fine, but since I do a lot of sandblasting, I have enough compressor to back it up. You want a big compressor with a high CFM if you're spending hours in the cabinet, but for small parts and short runs, you can get away with almost any 60-gallon compressor on the market. CFM is the measurement of how fast the pump can fill the tank, not how much air comes out of the hose. That's volume. The way I've had my cabinet set up for years, the air hose and the media hose came in from 2 different spots. The air came in through the factory location while the media came into the front of the cabinet. My mesh floor is cut smaller to drop it down, so that's not even really an option if you have it assembled the normal way. With the 2 hoses in 2 locations with 2 lengths, I found them fighting each other, and the solution that I came up with fixes this issue. To get better access, I removed the glass and I took the gloves off.
Yeah, well, just keep your power gloves off her, pal, huh?
I spoke highly about these green and black gloves in my other video, and I still believe that they're the best gloves I've ever had. The only reason that I switched the right one out is because the seam eventually split, but as far as the left hand goes, the glove is holding up way better than any other gloves I've used. Normally my left hand gets completely obliterated by the media after a few months, but these gloves are probably a year old and it still looks like new. If you're wondering why I have copper wire going to my gun, it's to stop static electricity from building up and shocking me while I'm blasting. It only happens to me when I blast powder-coated parts, and I don't do that often, so I'm going to leave it off moving forward. To clean things up with the hose routing, I'm installing a custom bulkhead that I make just for this application. It's made from stainless steel parts, and there are 1/2-inch MPT fittings for both the air and the media. I went with stainless because I've taken apart plenty of air systems, and the amount of corrosion that builds up is always surprising. The bulkheads are fully TIG welded and come with a pre-installed foam gasket laser cut to fit. You can find these bulkheads on my website lucidautoworks.com, and they're made in-house and have a black powder coated finish. To install the bulkhead, I provide a paper template to mark out your hole locations. The hose routing possibilities are pretty much endless, but for the outside I chose to use two 90-degree elbows to point the hoses down and keep the routing clean. The spacing is pretty tight, so I use a thinner wall fitting that came from Amazon. Links to everything I'm using are down in the description. I used a 1/2-inch barb for the air hose, and I stepped it up to a 5/8 barb and hose for the media. If you have a smaller compressor and smaller air lines to the cabinet, stick with a 1/2-inch media hose. You can see here that I chamfered the back of the fitting in the metering valve to smooth out the transition for the media.
Smooth move, Ajax.
I went on a little side quest while everything was apart and decided to seal up the gaps. I've had this same roof flashing on the chute for years, and it's held up great. I'm really glad I did this because it drastically cut down on the amount of dust that gets out of my cabinet. For the inside routing, I took a chance and I tried something a little different. With the way the hoses come in low and I'm always working from high, I found myself constantly fighting the hoses to get the gun in a comfortable position. I decided to extend them out a bit just so I could clear the door shield and then send them both up 90 degrees. This is the gun I use. You can see that my old one was very well used and it's long overdue to be replaced. I have a chamfered barb for the media, so I swapped that to the new gun. I cut my air and media hoses to length, and then I installed them on the barbs with hose clamps. It puts the gun in a much more natural position versus before where it had almost an S-bend in the hoses. I started to notice some diminishing performance after a while, so let me show you the modification that you might need to do to make the gun work correctly. So the problem I was having with the gun ends up being in the nozzle. I pushed it back to kind of exaggerate it and show you what was happening. The boron carbide tip ends up pushing its way back because there's nothing to stop it from working its way that way. That cone will fit around that opening, and once it slides its way back, you get absolutely no media flow. You just have air coming straight through and passing there. So you want to have this fully seated so it's flush there. And I just took a washer I had around. It's, a fender washer. It's bigger than 1/4 inch. And you can see it's starting to kind of clearance itself. It really should make itself as big as it needs to be. You might need to replace it. I might end up, making a laser cut part that'll be able to drop in and fill the gap more perfectly and have a bigger opening. But for now, this works. You just kind of drop it in place. You want it in front of the O-ring. And then you just screw the nozzle back on, and now because of that washer, there is no way for that to push its way back. And it works great. My glass modification has held up great, and if you haven't seen that video, I'll put a link to it in the description. I've been using the same piece of glass for around a year now. As far as the media goes, I use garnet sand. One thing that can cause a problem is putting too much media in the cabinet, so you just want to add a small amount when you get too low. I don't reclaim my media since it seems to get too broken up and too dusty, so I use a regular shop vac with heavy duty bags, and it's piped out of the wall to cut down on the hot air in the room. I did some test pieces like mill scale on hot rolled plate and a part that I powder coated before. It works great, and a part like this tire changer overarm that used to take me almost 7 minutes to blast in my original setup now takes about 3.5. If you want to support the channel, head over to lucidautoworks.com and pick up a bulkhead for your blast cabinet or some merch like one of our new hats or tees. I also have an assortment of other things along with my ultimate manual tire changer kits. Keep grinding away on those projects, stay lucid, and I'll see you in the next one.